Hey everyone, welcome back. We are making our way through lesson 4.7. And this is the second video. In the first video, you got a lot of explanation. And the big takeaways are this. We all year long have taken functions and done the inverse of those functions, which essentially means when we do the inverse of a function, take the x and the y values and swap them. And so the way we found out we could solve for a function was just to switch the x and the y's, and then re-solve the function or the equation for the new y value. Well, we ran into a little trouble when we tried to do that. We didn't know how to move the word sine or cosine or tangent to the other side, and so we found out there's kind of a way to do that, just creating a new term or a new symbol. You can see here on the board, this says sine to the -1. All right, that's the symbol for inverse sine, not the inverse that we mean 1 over sine, which you know is cosecant. This means, oh, we took the sine function and we swapped the x's and y's. Inverse sine, written like this, sometimes stated inverse sine, sometimes stated arc sine. And we can also write it with the word arc in front of it. This arc and this -1 exponent mean the same thing. They both mean we're going to flip the x's and y's, and we're going to take the inverse of these trig functions. And the whole reason for that is maybe instead of knowing an angle and wanting to find out what the sine is, maybe I have a sine value and I want to know what the angle that goes with it is. And so that's the big takeaway from the first lesson, is that we just understand what we mean by an inverse of a trig function. And the second big takeaway that we saw is when we did an inverse, let's say of a sine function, the sine we know has that sinusoidal wave. When we did the inverse of that, it kind of took that went along the x-axis and flipped it to the y-axis. And all of a sudden, we didn't have a function anymore. Okay, if I just asked you, what is the angle whose sine is √2/2? Well, it turns out there's an infinite number of answers to that because sine keeps repeating itself over and over again. And so what we had to do was we had to cut off a certain amount of values. We called them principal values, so that there was only one answer to that question. And so when we do inverse or arc functions, we just use the principal values. Your calculators already know this. And that way I know if I ask you the question, everyone's going to give me the same answer. So for sine and its flip, it's inverse that way, sine and cosecant. Also for tangent and its flip, the principal values go from -π/2 to +π/2. That will cover all the possible sine, cosecant, tangent, cotangent values, so that you will all give me the same exact answer if you get it correct. But cosine ran into a little trouble when we tried to use those same principal values. Turned out there were often two different answers that you'd be able to give me. So cosine's principal values go from 0 to pi. That's a little tricky. I think when you practice some of them, you'll kind of get that. We've referred to our trig wheel, and between these video lessons that I'm pre-recording, it occurred to me that maybe I'm going to send out another trig wheel that's even a little more detailed, in that it gives all the angles of all the special angles in both degrees and radians. It gives the unit circle x and y values. And you know those are important in a unit circle because that gives us the cosine and it gives us the sine. And from that, we can find the tangent. And I've also kind of penciled in when we go backwards, right? I don't know if you all can see this from here, but you've got it included in what I sent out to you. When we go into negative values, I just kind of stated what those negative special angles are: -π/6, -π/4, -π/3. So you can reference that a little more easily. You're going to want to have a trig wheel handy as we go through some of these examples. It's going to make life way easier. You're going to see we're going to make use of our calculators a little bit too, although when we're asked for exact answers, if they involve irrational numbers, please remember your calculator is not going to cut it. That's why we can refer to this circle, and we'll see it's going to be really helpful to us. So let's jump in with some examples. The fact is, because we know all this about special angles, all this information that's in this trig wheel, we can answer some basic arc or inverse trig questions. I have a few written there on the board. You might want to write out on a piece of paper or in your notebook. This says arc sine root 2 over 2. And again, it's good for you to translate what that exactly means. What is the angle whose sine is root 2 over 2? What's the angle whose sine is root 2 over 2? I know the sine value. I want to find out the angle. And what you got to remember is my principal values. Okay, that goes from negative pi over 2 to positive pi over 2. So I'm going to look at my wheel, and I'm just going to find out, all right, where is the sine value, which I know is the y value on the unit circle. Where is it root 2 over 2? And if you do all that correct, you find it pretty quick right at pi over 4. That's the angle, the only angle in the principal values that has a sine of root 2 over 2 is pi over 4. Okay. Let's do a cosine one. If you can see right next to it, it says, what is arc cosine negative root 3 over 2? Another way of saying it, what is the angle whose cosine is negative root 3 over 2? And again, if I use the same principal values, if I use the sine values, I'm struggling even to find a cosine in the negative. So that's a problem, but we have to keep in mind for cosine, my principal values go from 0 to pi. And so I'm going to look from 0 to pi, and I know cosine is the x values on a unit circle. And so I'm going to find where the cosine or the x value is negative root 3 over 2. And I find my angle all the way in the second quadrant, and it's 5 pi over 6. Hopefully you guys can see that and find that. 5 pi over 6. That's the answer. All right. If I'm armed with this trig wheel with all this information, it makes finding the exact values of these special angles pretty easy. Okay. We can do a tangent one. The only thing that's a little bit trickier with tangent is you have to remember, how do we find tangent? Tangent is sine over cosine, or y over x. And so you might have to go ahead and do some of those math values. This wheel I sent you just now, if you look in the first quadrant, it also gives the tangent values, which we could use these as reference angles to do in the fourth quadrant. When we go into the negative values, you can just take negative values of those. You'll understand, you'll see as we practice along. But this says arctan root 3. What's the angle whose tangent is root 3? And I look in my principal values from negative pi over 2 to positive pi over 2. I think when tangents are positive, I'm in the first quadrant. And if I look carefully, I can see, oh, tangent is root 3 at pi over 3. That's my correct answer. That's all it is. We're given the trig value, the tangent or the sine or the cosine, and then we're asked to find what the angle is that goes with it. All right, that's not all too bad. Now, this trig wheel is super helpful when it's any of these special angles, but there's an infinite number of angles in between. And so you need to know that we can refer to our calculator, because our calculator has those buttons above the sine, cosine, and tangent buttons. If I hit the second button, it will tell me arc sine, arc cosine, arc tangent. It's just that it will take irrational numbers and it will round them off. I can't be as exact, but sometimes that's the best we can do. That's all we can do. I mentioned before, your calculator knows principal values. So when you ask it an arctangent question, it's going to give you an angle somewhere between negative pi over 2 and positive pi over 2. When you ask it arc cosine, it's going to give you values somewhere between 0 and pi. And so we could use calculators, and I'm going to write a couple of examples on the board, but you should have a calculator handy because that's how we're going to find it. Again, cosine to the -1 is another way of saying inverse cosine or arc cosine. 1/3. That's not the same thing as pi over 3. This is just 1 over 3. It's not a special angle. It's not anything that I know. And so what we're going to have to do is we're going to have to go to our calculator. I'm sure your calculators are set in radians, but double check that. Make sure that they are. And we're just going to have to say second cosine 1 divided by 3, 1/3. And we get the angle, again, in terms of an irrational number. When we do angles like on that trig wheel, mostly they have pi in them. This just tells us that the angle is 1.23. And so that's what we'll go with. All right. Try another one. Arctan, tan to the -1 of -35.85. All right. What is the angle whose tangent is -35.85? And I don't know if that looks tricky or not, but it's super simple because it's just a calculator question. We do second tangent or arctan -35.85. And I get an angle of -1.54. And so if you have questions that don't fall on these special angles, might seem worse, it actually makes life a little easier. We can just refer to our calculator, and we're just going to have to round things off as best we can, right? Want to talk a little bit about something you may or may not remember, and that's the composition of functions. We learned when we did inverses, if I did a composition of a function and its inverse, I always got just back to x, just straight up plain old x. And I want to show you how that makes sense. And it's the same thing here. And we're going to practice doing some composition of functions. But let's take a look at this. Might look scary or hard at first. This says sine arcsine 1/2. And I do notice, boy, these two things look really similar. In fact, they are inverses of each other. But let's just understand what exactly is being said here. We'll see how kind of easy this answer is. First of all, we always start from the inside and work our way out. So inside here in the parentheses, it says arcsine 1/2. What's the angle whose sine is 1/2? And you can go and consult your wheel again. I know sine is the y value. It looks like the angle I'm talking about is pi over 6. So if I just did in the parentheses here, the answer to that is pi over 6. And I've taken care of everything in parentheses. So now the question says, I'm just bringing that sign down. What's the sine of pi over 6? Let me look at the wheel, pi over 6. The sine is 1/2. And so what I want you to see is all that did was take me right back to the beginning. I did the arc sine of 1/2, and then I did the sine of that, and I ended up right back at the beginning, right back at my x value at 1/2. And so you're going to have some of these in your homework, and they're going to seem real complicated. And really what they're doing is they're bringing us back, right back to the beginning. There's a couple of slightly tricky curveballs, and I want to find a couple of those and do them with you. But we'll put some examples on the board, and we'll take a look at some of the tricky curveballs that might happen. Here's what else we can do then. We can mix when we do compositions of functions. It might not just be sine and arc sine, cosine and arc cosine. It might be cosine and arc sine, sine and arc tangent. And so we'll play with some of those in a second. But do me a favor, write down these examples. You're going to see how some are super easy and some have a slight curveball or trick to them, but there's only a couple of tricks that might be able to happen. So you'll figure these out pretty quick. I'm going to write these examples on the board. Cosine of arc cosine 0.6. This time we're going the other way. Arc sine sine 3 pi over 2. And last one, cosine arc cosine 1.5. And these three examples are picked very purposefully. One of them is going to show you how easy this often is. And then two of them are going to be those slight tricks that we just have to watch out for. So pay close attention as we do these. First of all, each of these, it looks like I have a regular trig function and its inverse or arc function together. Seems like they should cancel each other out. And in fact, let's look at this first one. It says arc cosine 0.6. What is the angle whose cosine is 0.6? That's definitely not a cosine value that is on my trig wheel. I might feel like I should go to the calculator then, and you can do that, but hang on one second if you want to do that. Let's just look at this. I have some angle whose cosine is 0.6. And then I want to take the cosine of that angle. Think that went through for a second. We just did an example before. What angle has a cosine of 0.6? And then what's the cosine of that angle? Hopefully you see it just takes us right back to the beginning. These are inverse functions, and they bring me right back to my x value. The answer to that is 0.6. Go ahead and verify that on your calculator. We'll do second cosine, sorry, my bad. We're going to do cosine of second cosine 0.6. Get a couple of parentheses in there. And if you look, it just says 0.6. Got us right back to the beginning. So hopefully that makes sense to you, how and why that works. And you'll have a number of questions in your homework that are that simple. It just takes us right back to the beginning. Let me show you why these are just a little tricky, these next couple. And let's start with this one. Again, we can use our calculators, but it's not going to get us the right answer on a quiz or a test because this involves one of the special angles. All right. And when we have special angles, we need to be exact. Actually, this one might be okay. I'll show you why this one might work and some others might not work. It looks like these are inverses of each other. And so they should cancel each other out, so to speak. I should be right back with my x value. The problem is this. The last thing I'm asking for is an arc value, an inverse value. And 3 pi over 2 does not fit into my window of values. All right. 3 pi over 2 is not in my principal values. And so what I'm going to do is I'm going to find the sine of 3 pi over 2. And if I look at my wheel, okay, I go around 3/4 of the way around the circle to 3 pi over 2, and the sine is the y value, and the sine of 3 pi over 2 is -1. All right, everyone got that? If I just did this, the sine of 3 pi over 2 is -1. So now I want to find the arc sine of -1, the angle whose sine is -1. Problem is, when I do arc sine, I have principal values. I have to go only from negative pi over 2 to positive pi over 2. And you might look down and you might say, well, okay, 3 pi over 2 is the same thing as negative pi over 2. And I do have that labeled on the new wheel that I sent out. And so that, in fact, is the correct answer to that question. They even look like they're at the same place. They are. They're coterminal angles. But this is the only answer that fits in the window of principal values. So sometimes when I have things that seem like they cancel each other out, I have to be careful because this angle 3 pi over 2 is not a principal value angle. And so it's got to be adjusted to give me an angle in principal values. That's one of the curveballs we might hit. The other one, if you think it through, if you're not just kind of going by rote memory, but can think through what these say, this might be more obvious to you. Cosine and arc cosine seem to cancel each other out. But if I look in the parentheses, arc cosine 1.5, what's the angle whose cosine is 1.5? What's the angle whose cosine is 1.5? Well, if you think about it, cosine is never 1.5. Cosine never goes above 1. It never goes below -1. So a little bit of a trick question. The angle whose cosine is 1.5 does not exist. If it doesn't exist, I sure can't find the cosine of it. We might say undefined. And your calculator would get that, by the way. Your calculator would have an issue trying to find the angle whose cosine is 1.5. Let's put this one into our calculator. We'll say, what's the cosine of arc cosine 1.5? And it's telling you, oh, I don't like that. There's an error. Something doesn't work. So we might want to look for just these couple of two slightly tricky things. Remember, this one was just a little tricky in that there was an answer to it, but the one that seemed like the right answer didn't fit into my principal values. And so I had to adjust and make it fit into principal values. And this one, even though these two seem like they cancel each other out, I don't have any angles that have a cosine of 1.5. And so that was undefined. All right. Other than that, we will make really good use of this wheel, and we can mix and match some values. And also what I want you guys to see is even if there are angles that don't fit on our trig wheel, we can play a little game with triangles and be able to figure those out. Let me show you first just one where we can use the wheel. What if we were asked in the homework, okay, this time we're doing a composition of functions. We're doing a function of a function but they don't cancel each other out. Sine and cosine are not inverses of each other. And so let's just work from the inside out. This says arc cosine root 3 over 2. What's the angle whose cosine is root 3 over 2? And I take a quick peek at my wheel and I'm like, oh, that angle is pi over 6. So I just fill that in the parentheses, pi over 6. And now the question becomes, what's the sine of pi over 6? And again, I look at my wheel and I'm like, oh, that's the y value, 1/2. So 1/2 would be the answer to that. Not hard. We're just going to work from the inside out. We're going to use our wheel. We're going to understand what arc functions mean and principal values. We're going to remember or recall what a regular sign means on a unit circle. It's the y value, and we're going to be able to solve those. So this one involved an angle that was one of those special angles that we knew. Let's look at one that might seem a little trickier because we're actually not ever going to know the angle or identify the angle. Then we'll let you practice after that. This says cosine arctan of 5/12. Don't like this one immediately because these two are not inverses of each other, so it doesn't take me right back to the beginning. Also, the angle whose tangent is 5/12. Well, that's not a tangent value that I'm really familiar with. I don't think it's one that comes up on my wheel, but I want to show you that we could easily kind of build a little right triangle on a graph, and we can come up with this. First of all, remember tangents, arc tangents, principal values are from negative pi over 2 to positive pi over 2. But I notice this tangent value is positive, and so it's actually going to be in the first quadrant. Any of the angles in the fourth quadrant would have given me a negative value. So here's what I want you to see. Somewhere up here in the first quadrant, I have an angle. Let's call that angle theta. And we're never going to discover what theta is, but we're still going to answer this question. I know that the tangent of theta is 5/12. Well, that means I could build somewhere, I could build me a right triangle, and I can remember that tangent is opposite over adjacent. So somewhere I can drop a vertical line at the perfect spot that this is length 5, and that's length 12. Okay, still don't know what this angle is, but I do know that this angle has a tangent of 5/12, which is what this means. Arctan 5/12. What's the angle whose tangent is 5/12? Well, looking at this right triangle, if I wrote it out correct, I could figure out the hypotenuse. I'm not dealing with unit circles anymore. It's not a hypotenuse of 1. I'll do the Pythagorean theorem real quick, and you can do it on your own, but I'm just going to let you in to keep this video a little shorter, that it is length 13, right? So I've got some angle whose tangent is 5/12. Still haven't figured out what that angle is, but it doesn't matter. I want to know what's the cosine of that angle. All right, well, the cosine is adjacent over hypotenuse. So it turns out adjacent over hypotenuse is 12/13. That's the answer. Cosine is 12/13. And all I did, I never found theta. I never figured out exactly what theta was, but I built a right triangle to be able to mix and match here. And those are going to be the final ones that you're going to be practicing on. I want to remind you, let's always work from the inside out if I have parentheses. And you can see on your notes what the homework questions are, and I will print those. And again, make sure you use that special extra unit circle I gave you that just has all of the information that you need. Good luck. Come with your questions. We'll figure this out together.